Okay, so in this video, we're going to talk about the law of sines. And the goal here is going to be kind of to talk about what is the law of sines, and then just to give an example of how you would solve for a side with the law of sines and solve for an angle with the law of sines. One really important thing I want to talk about is that this is a very basic introduction. If you are in a class and your teacher has used the words ambiguous case, this video is not for you. You will miss out on that ambiguous case stuff if you are discussing that in your class. Otherwise, if you are not concerned with the ambiguous case, if your teacher has never said those words before, you should be good in this video. So let's go ahead and get started here. The law of sines is essentially just a formula that we can use for solving triangles that are not right triangles. And so if we have any particular triangle at all, I'll go ahead and start by just drawing a triangle out on the paper. The law of sines will give us a way to solve for something missing. The first thing we got to talk about is just the naming conventions here. So when we use capital letters, we are always referring to the angles of a triangle. So angle A would be this angle B would be this angle C would be this angle. And the lowercase letters are going to be the sides that are opposite. So from angle A straight across is side A. From angle B straight across is side B. From angle C straight across is side C. Then our law of sines just says that the sine of an angle divided by its opposite side is equal for every angle in the triangle. So sine of A over A equals sine of B over B equals sine of C over C. We don't really even need all of those if we just remember that it doesn't really matter what variables we use. The sine of an angle divided by the opposite side is going to be equal to the sine of an angle divided by the opposite side within the same triangle. So let's go ahead and take a look at some applications of this. Solving for a side is going to be the easiest place to start. So I'm just going to go ahead and draw out a triangle for you. Make it pretty big here. So I'm going to say this one is 82 degrees, 70 degrees. This side is 5, and we're going to solve for that side. The first thing you're going to have to notice here is that these are going to come in pairs. So a side angle pair there, and a side angle pair there. We have to know one of those pairs completely. So an angle and its opposite side that we know completely, and then another pair that we know one of. So in this green pair, we know the angle, but not the side, but in the red pair, we know both. That's important. When we go to start solving these, I'm going to show every single thing, writing it down. If you are having any trouble at all with these, I would encourage you to show everything. The whole point of algebra is to keep it written on the paper. It makes it easier. Yes, it is more writing, but it makes it easier. So I'm going to write out my equation, my formula, and I'm going to go ahead and start plugging things in. You notice I just used A and B. We only need 2 of them to make a proportion, so we're only going to worry about those. I would always start with the one that I know first, so the 82 degrees and the 5. 82 degrees is my angle, so it's sine of 82 degrees divided by the opposite side, which is 5, equals, now I'll do this one I have circled in green, my 70 degrees is my angle, so sine of 70 degrees over the side we don't know, or x. So as with any algebra equation, it started off with 4 variables, but we have to know 3 of those to be able to solve for the 4th one. We can only have one unknown in any equation that we want to be able to solve for. So next up, we've got our stuff plugged in. Now I just want to make sure we kind of connect this back to algebra. Anytime you have a proportion, even though this one's weird and has sine in it, proportions are solved by cross multiplying. So I'm going to cross multiply 5 times sine of 70. I'm just going to write out 5 times sine of 70 degrees. I'll go ahead and cross multiply the other direction while I'm at it. Maybe. we go. Equals x times sine of 82. I want to see that written out. Now we are solving an equation. We've cross-multiplied to get an equation, and we want to solve it for x. The thing we want to do to solve it for x is we have to get rid of the sine of 82. And since it's being multiplied by the x, algebra tells us that a good strategy would be to divide by the sine of 82 on both sides.
Did you send one of
So we'll divide by the sine of 82 on both sides. It'll cancel out on the right-hand side. And at this point, we have solved our equation. We have it so it says x equals this whole mess over here. This is the point where we just want to go and type that into our calculator. So let me go ahead and pull my calculator over here. We'll make it a little bit smaller, hopefully, so that it fits. Here we go. And we're just going to start typing these in. So we are going to do 5 times the sine of 70 degrees. I'll go ahead and close my parenthesis. Divided by the sine of 82 degrees. Close my parenthesis. And there you can see my answer is 4.7. I'll go ahead and make that a little bit bigger. 4.7. So that is our length of our side, 4.7 for x. The big thing there you might have noticed is I did not touch my calculator till the very last step. We are relying on our algebra skills to solve this. We do not want to get a calculator involved until the very end, so we can just type it all in as one. Make sure we're getting that calculating done right. There's too much room for mistakes and rounding and being off if we start trying to get a calculator in there earlier. So trust your algebra. Plug it in. It's a proportion, so we cross-multiplied. We went, oh, x times something. We better divide by that something, and we're done. Okay, solving for an angle is not too much more difficult. So I'll go ahead and draw this next problem out here. I'm going to go with 110 degrees there with a 13-degree side across from it, and 8 degrees or an 8 side there, and x right there. So this time, when we look at our pairs, we've got a pair that we do know, which is good. We have to have that pair. And in the other pair, we don't know the angle, but we do know the side. So we have what we need to use the law of sines. I'm going to go ahead and write out my equation, write out my formula. I guess it's a good idea to write the formula every time. And then we'll go ahead and start plugging things in. I'm going to color code a little bit better on this one. So my 110 degrees and 13 are going to go in for big A and little a. So sine of 110 degrees over 13 is equal to the sine of, we don't know the angle, so sine of x over 8. So the big difference here is the unknown thing is an angle. It's got to go in the sine, right? Angles, sine of angles. We can't take sine of sides. Okay, our next step is algebra. We look at this thing and we go, I've been able to solve proportions for a while now. I can cross multiply. It looks different because it has the sine in there, but it's still a proportion. So 8 times sine of 110. Write it out. Equals 13 times sine of x. Just write it out. Don't change anything. Exactly what you would say when you were describing the cross product. Now this one's going to look a little different because the x is stuck inside of this sine function. So we're just going to kind of peel this thing back one layer at a time. The first thing that's really easy to get rid of is just 13. It's 13 times the sine of x. Well, the opposite of times is divide. So I'll just divide by 13. On this side, it cancels out. On this side, I'm leaving it alone. I'm not typing anything into my calculator yet because I don't want to. I'm going to keep that for the last step. So over here on this side, I still have sine of x. But on this side, I've got this whole big thing that I'm just going to write down. As bad as this is to have to write down every time, the alternative is to keep it in your head. And that is really hard. Now, once we get to here, I want you to think back to what we were doing with just normal right triangle trig. Anytime we ended up with an equation like sine of x equals 5 over 12, our thought process went, oh, we can use an inverse. So we'd use the inverse sign to get x. That just swapped. And I wrote that backwards from what I wanted to. I'm going to go ahead and get rid of this. So when we had sine of x equals, we swapped that around. So we would go ahead and write x equals and use the inverse sign. And that would just switch everything around. We'd put the 5 over 12 in here, and it would give us the x out. Inverses just switch inputs and outputs. So instead of saying that the sine of the angle equals this fraction, the inverse sign of the fraction equals the angle. And that's exactly what's going to happen over here. We have sine of an angle equals this fraction. So in order to find the angle, we are going to go ahead and write it as the inverse sign of all of this stuff is equal to x. It just switched around. Instead of the x being inside of sine, all this stuff is inside of the inverse sign. You can go ahead and rewrite it if you want. Not sure if I have enough room. Pretend you can read that. Most of the time, I won't actually write anything in those parentheses. I'll just circle it and draw an arrow so I know what to do. And so again, we've got it so that it says x equals now. We are done with our algebra. We have solved the problem. The only step left is to type it in a calculator. This last step really isn't even part of the math. It's just, if we want a number for an answer, we better go ahead and type it in. So inverse sign is hiding under this function. Then on top, we've got 8 sine of 110, or 8 times sine of 110. Close our parenthesis. And then before we close this parenthesis on the inverse sign, we want to divide by 13. And then if you really want to, you can close that parenthesis. You'll notice that this looks exactly like what I'm writing. If you do your algebra correctly, if you show the algebra the way you're supposed to, you type it exactly into Desmos, and it'll tell you the answer. Because we already solved it. Desmos is just saying, well, what is this big thing equal to? And it's 35 degrees. We were solving for an angle, so remember this is 35 degrees. And that's how we solve for an angle with law of sines. So that's pretty much the only two things you can do. You can solve for a side, you could solve for an angle, and there is more to this than we're showing here, but that is going to be something that you probably learn more about later on. This is a very basic introduction to the law of sines. We just want to get you used to this, and honestly, you're practicing your algebra, which is great. We need more practice on that algebra.